Hey everyone, welcome back to the College Algebra playlist. So far in the playlist, we've done 6 videos on functions. Alright, so what I want to do in this video is take everything we've learned about functions and apply it to some concrete examples. Alright, so let's dive into it. Okay, here we go. Example 88. Here we're asked to find the domain of the function. Alright, and we're also asked to report the final answer in interval notation. Okay? So here we can see that we have a factored cubic polynomial function, all right? And we can see right away that we can plug in anything we want for x without worrying about division by 0 or taking the square root of a negative number, okay? So if the function looks like this, we can plug in anything we want for x, all right? Which means that the domain is all real numbers. All right, and in interval notation, the way we report that is we say everything from negative infinity up to positive infinity, like this. All right, so that's our solution. Moving on, here we're asked to find the domain of the function again. All right, we have f of x equals 3 times the square root of x minus 2. All right, remember in this playlist, we're only dealing with real valued functions. All right, we don't want to have anything complex going on when we're looking at functions. All right, so we need to take this stuff inside the radical and set it greater than or equal to 0. All right, we're taking the blue stuff and setting it greater than or equal to 0. All right, that way we can ensure that we're not taking the square root of any negative numbers. All right, so when we solve for x here, right, we add 2 to both sides, and that gives us x is greater than or equal to 2. All right, which means that the domain of this function is everything from 2 up to positive infinity. And 2 is included, so we use a bracket right there. All right, and this is our final answer. All right, moving on. Here we're asked to find the domain of the function again. All right, and we have a rational function here, right? F of x is rational. So what we need to do is watch out for division by 0, right? I don't know what value it is, but there's a problematic x value that when we plug in here, when we plug it in here, we get division by 0. All right, and that's not allowed. Okay, so we need to set some kind of exclusion in the domain, right? We need to find that problematic x value. So to do that, we're going to take this denominator and set it equal to 0 and solve for x. All right? So when we isolate x here, right, we subtract 2 from both sides, okay, and that gives us this. And then we divide both sides by 4, and the 4's cancel on the left-hand side, and that gives us x equals negative 1/2, right? Negative 2 over 4 reduces to negative 1 over 2. Okay? So this is the problematic x value that causes division by 0. All right? So we're going to exclude this value from the domain. All right? And when we report that in interval notation, it looks like this, right? It's everything from negative infinity up to negative 1/2, union everything from negative 1/2 up to positive infinity. All right? So this is our final solution. Here we're asked to find the domain again, all right? And we can see that we have 2 things to worry about, all right? This is a rational function, so once again, we need to worry about division by 0, all right? We can see that if we plug in x equals 3, we'll get division by 0, okay? So we need to exclude x equals 3 from the domain, all right? And we also need to set this stuff inside this radical greater than 0, all right? Notice that it's strictly greater than 0, okay? So when we solve for x here, we add 3 to both sides, and that gives us x is greater than 3. All right? The values for x must be greater than 3 in order for us to be taking the square root of non-negative numbers. All right? So x is greater than 3, and 3 is not included, so we use a parenthesis right here, right? We have 3 to infinity, and that's our solution in interval notation. All right? Moving on. Here we're asked to find the domain and range of the function whose graph is shown below. All right. So we're just going to look at this function, right? We'll just eyeball it and we'll determine what the domain and range are. All right, the domain, right? That's all of the x values in between these 2 points here, right? We have a circle here at 1, 4, so it's not included, and we have a point here at 4, 3, so it is included. All right, which means that the domain, right? That's all the values in between 1 and 4, and 1 is excluded, but 4 is included. All right, so we use a parenthesis and a bracket respectively. All right, that's our domain. Okay, and the range, we say those are all the y values in between these points. All right, so we have everything between 3 and 4, 3 included, but 4 not included. All right, so that's the range. Let's take a look at one more problem like that. All right, where we find the domain and range just by eyeballing the function. All right, here we have the lower half of an ellipse, right, and it extends from -4, 2 up to 3, 2. All right, and we have a point and a circle. All right, so the domain, right, that's all the x values in between -4 and 3. All right, -4 included, 3 excluded. All right, so that's our domain. And for the range, we can see that this graph comes down and kisses the x-axis at a height of 0, right? So the y values are everything between 0 and 2. And 0 and 2 are both included. You say, Luke, why are you including 2, right? It's a hole here, right? And then to that I would say, look at this point over here, right? 2 is not included over here, but it is included over here, okay? So we can put 2 in our range and we can put a bracket there. All right, so that's the domain and range of this graph. Here we're asked to simply sketch a graph of the piecewise function. All right, so remember, a piecewise function is defined by multiple formulas and it has many domains that go along with those formulas. All right, if x is less than -2, all right, this function says to take the input and add 1. All right, so this is the line y equals x plus 1. All right, that's a line with slope 1 and y-intercept 1. All right, so this line comes down here and it comes up here and it stops at -2 and -1. All right, there's a hole right here. All right, and then if x is greater than or equal to -2, we have this line, y equals -2x minus 3, and it looks like this, right? It's a line with slope -2 and a y-intercept of -3. All right, so we have a circle here for this blue part because -2 is not included, and we have a point here in red because it is included in this mini domain. All right, so this is what the piecewise function looks like. Here we're asked to sketch a graph again, all right? But this time the piecewise function is defined by 3 pieces, all right? So let's just plot each of these pieces one at a time, all right? And see what we get, okay? First of all, we have y equals -1/2 x in blue if x is less than -2, okay? So that's this line right here, all right? It comes down here and it stops at -2, -1, -2, +1. All right, and then we have the red line, y equals 3. Okay, so that's just the flat line, y equals 3 up here, and x is in between -2 and 0. Okay, and finally we have this green curve, right? Y equals the square root of x. That looks like this, right? If x is greater than or equal to 0, this is what the function looks like. It's this swoosh. Okay, so the piecewise function looks like this. Let's move on to the next example. All right, here we're asked to evaluate f at -2. All right, so we're given the function, right? This is the piecewise function, and we're given a picture of the function. All right, so that'll help. All right, and we're asked to evaluate. All right, so we're going to plug in the value x equals -2 and see what we get out. All right, what's the output of f? -2 is less than +2. All right, so we need to take a look at this blue formula. All right, we're going to use the blue formula to evaluate f. Okay, so we have the input squared minus 2. All right, so we take our input -2 and square it and subtract 2. All right, negative 2 squared is positive 4. So we get 4 minus 2, which is equal to 2. All right? So f of negative 2 is positive 2. All right? Which means that the point negative 2 comma 2 is somewhere on this graph, and we can see that it's right here. Right here. All right? Moving on to part B, we're asked to evaluate f at x equals 2. All right? So take a look at these mini domains. X is strictly less than 2 here, so it's not included. And then here, x is greater than or equal to 2. So 2 is included in this mini domain. So we need to take a look at this red formula. All right, we use the red formula to evaluate f. All right, f of 2 equals 4 plus the absolute value of 2 minus 5. All right, and that gives us 4 plus the absolute value of negative 3. And the absolute value of negative 3 is positive 3. So we get this, which is equal to 7. All right, f of 2 is equal to 7, which means that the point 2 comma 7 is somewhere on this graph, and we can see that it's this red point right here, 2 comma 7. All right, one more part here. We're asked to evaluate f at 6. All right, so 6, once again, is greater than or equal to 2, so we're going to look at this red formula again. All right, f of 6 is equal to 4 plus 6 minus 5. All right, and 6 minus 5 is just 1. Okay, so we get 4 plus the absolute value of 1. And the absolute value of 1 is just 1. So we get 4 plus 1, which is equal to 5. All right, f of 6 is equal to 5. So the point 6 comma 5 is on this graph somewhere, and we can see that it's right here. All right. Let's move on to the last example. All right, this is a word problem. All right, so fasten your seatbelt. The cost in dollars of making X items is given by the function C equals 10x plus 500. All right. The fixed cost is determined when 0 items are produced. And we're asked to find the fixed cost for this item. All right. So we have the function formula, and we also have a picture, right? This picture will be useful when we answer these questions. All right. So the fixed cost happens when we plug in 0 into this function. All right. So let's just do that and see what we get. All right. Let's plug in a 0 and find out what the output is. All right. C of 0 equals 10 times 0 plus 500. All right. 10 times 0 is just 0. So 0 plus 500 equals 500. All right. So we have C of 0 equals 500, and this is our fixed cost, right? It costs $500 if you make 0 items. All right. So the point 0 comma 500 is on the graph, and it's right here, right? This is the y-intercept. Or rather, I should say, this is the c-intercept. All right. Next, we're asked, what's the cost of making 25 items? All right. This function, right, this is c as a function of x, all right? So x, the number of items, is the independent variable, and the dependent variable is the cost c, all right? So let's find out what the output is when we plug in 25, all right? C of 25 equals 10 times 25 plus 500, all right? And 10 times 25 is 250. All right, so we have 250 plus 500, which equals 750. All right. So when we make 25 items, the cost is $750. All right, which means that the point 25 comma 750 is on this graph somewhere, and we can see that it's right here. All right. One more part to this problem. All right. It tells us that the maximum cost allowed is $1,500. All right, so the company that's making these items, it's not looking to spend any more than $1,500. All right, we plug in some value for x, and we get 1,500 up here. All right, and we need to find out what that x value is because we're asked what are the domain and range of the function z of x. all right? So we know that this point here is 0, 500, right? We found that in part A, all right? But up here, we have an unknown x value, right? We need to find what this x value is, okay? So let's solve this equation here, all right? If we have 1500 for the output, we want to know what the input x is, all right? So what we do is we subtract both sides by 500, and we get 1000 equals 10x, all right? We're isolating x on the right-hand side, okay? And then we divide both sides by 10, and we get x equals 100, okay? So that's the missing value we're looking for, all right? The point 100, 1500 is on this graph, all right? And it defines the boundary of the domain and range, all right? Just like this point does over here as well, okay? So now that we have these points, we can just eyeball this function, right? We can just look at this graph and write down what the domain and range are right away, all right? The domain, right, that's all the x values in between this point and this point. So it's everything from 0 to 100, and 0 and 100 are both included, so we use brackets, all right? That's the domain. And the range, right, that's all the y values in between these 2 points. So it's everything from 500 to 1500. And they're both included as well, so we use brackets. All right? That does it for this video. Thank you for watching, and like and subscribe.